There we go. So now we're recording. Problem said D, no B. I haven't started marking yet, so I have no idea what you guys are doing. However, there are a few things I want to talk about because next week you have your quiz too. So a few things I do want to talk about. The first is if you prove two sets are equal, you do not use set identity. You use double inclusion. Okay, you prove the two sets are subsets of each other. You do not use set identity. Why? Because you only need two set identities. For any other identities you want to use, you need to give a formal proof, which is again double inclusion. So please, worksheet, I will send it to you, don't worry. It's not 10 yet, so I plan to send it to you at 10 o'clock, at 2:10, but I'll send one now and I'll send one after 10. Yeah, that's a tutorial worksheet. Based on my last tutorial, we do not have time to go over everything. I only did 2 questions in my last tutorial. I do not know how. I was really slow for some reason. I think it's because we talked too much. So for this tutorial, I will do the same 2 questions, and for the rest, I'll just record a separate video and talk about the rest. That's it. What else? Do you guys have any question for me? Questions? Yes, no, anything? We're not at 10 yet, so you can ask anything. There are many of you. Are all of you my students? I feel like I do not have this many students. Quiz average. I'll tell you. I'll put in the chat. So I'm not gonna tell you. Put in the chat. It's this much. Quiz average. And over this many students and submit, and over this many students got 100%. Median. Let me have a look. It's not bad. It looks pretty good, to be honest. Past years, I'll type in the chat too. Past year quiz 1 average is around this to this. Quiz, let me check the median. I don't think you improved. I don't think it has anything to do with that. I think it's because I did almost identical question for the number 3. So a lot of you basically did what I did. But last year they didn't get that. And also our marking scheme is quite linear. So we did not, I think it's quite linear. So median, I do not know the median because they do not tell you. They tell me average, high score, low score, standard deviation. Standard deviation is this much, but no median. This is the standard deviation. Do you think post requirement will go up? I have no idea. I think you should aim for 80 plus to be safe, because they used to make it at 80 plus, and only because of COVID they lowered it. What do you mean quite linear? You lost the marking question to for, well, if you are skipping steps, you'll always lose mark. No matter who's marking, you always lose mark. A step, yeah, still you'll lose mark. 102, you need to write every single step down. Lenient as some of you, you made like a small mistake and we let it through, we did not deduct mark. For example, no, like for example, some of you made a typo in between and then just let it pass. Or some of you, you're supposed to write plus, you wrote minus, and the whole thing is minus, but it was supposed to be plus, and I just let it through. That's us being lenient on you. And some of you use really wrong notation for something. We did not deduct mark, so that's being really nice already. You did not see, okay, those are nothing. When I was taking a course, I all my proof is correct. I made a single mistake at the very last step. The very last step. It was like addition. Add two things together. I added them wrong. I lost 5 marks on that. So it's nothing, guys. It's really nothing. I went to my TA and my TA is like, oh, this question was 20 marks and I only gave 0, 5, 10, 15, or 20. You made one mistake, so let's deduct 5 marks. I was like, okay, fine, bye. We are being really nice to first years already, so no complaint. It's you just need to accept your fate. No, I'm just kidding. You can complain. Blame on me, okay? Blame on me. If you think it's too harsh, blame on me because I made the marking scheme. I mean, I didn't make the whole thing. I gave them a rough marking scheme and they can change in however they want. I'll just have a look and see if it's fair. But blame on me if you think they mark too hard. And you can tell everyone to hate me. That's okay. I'll accept the blame. Don't blame my TAs, our TAs, 102 TAs. It's okay. They're quite good. They're quite nice. You're going to die. You're not. Everyone's gonna die. It's like people who drink water has 100% death rate, which is not wrong because everyone's gonna die and we drink water. Anyway, I think that's it. Due to one such to my life expectancy is so much shorter. You mean 102? It's a fun course. Come on. Now I'm forgetting what I was gonna do. I really thought question 3 was gonna be marked. It's not being marked. I don't want to mark it because I have my reasons. I don't want to mark it because I want to mark the questions that can give you good feedbacks. So such as like set equality questions that can give you good feedback so you can avoid the mistakes you made in your problem set so you can do better on quiz 2. However, if we mark that question, it's basically either you see it or not. So that's not good feedbacks. So we're not marking it because because problem set is a place you make mistakes and we give you feedback so you don't make the same mistakes again. Yeah, that's basically the reason. Don't try to guess what I want to mark, so otherwise you will fail this course. I'm serious, because I've had people like students guessing what I'm gonna mark or what we are gonna mark, and they guessed wrong, so they didn't submit the questions we are marking, and they got 0. They did the questions we are not marking, and did not submit the question we are marking, and they got 0. If the question says briefly, then it's briefly. You do not need the formal proof. If they say justify, explain, proof, then you need formal proof. But if they mention the word briefly, then you do not need a formal proof. I'm not answering that question. You need to figure it out yourself. Your brief explanation is a paragraph? Who's your TA? I'm not your TA, right? Tell me I'm not your TA. I really hope I'm not your TA. I do not want to read paragraphs or essays. switch to other tutorials, please. How do I know who's yours? You still don't know who your TA is? That's bad. I feel bad for your TA. If I'm your TA, I feel bad for myself. Come on, you check. I can't believe you don't know. You check Quarkus, you click, yeah, your official TAs are the one who marks them. So the tutorial you are enrolled, that TA for that tutorial section is gonna mark all your problem sets. I wasted so much time already. Oh my god, guys, let's do. I am your TA. I got so passionate. Oh, how? I feel bad. Okay, although I wasted so much time, I still want to tell this story. So before like a few years ago, 102 back in person, we were not using Quadmark. Everything was like on paper. So basically, when you go to your tutorial or when you go to write the quiz, you need to circle your TA's name, right? So you need to circle your TA's name, so your paper will be graded by your own TA for the quiz. That's how it works before. And a student for the whole semester, so we had another TA called Muhammad Reza. One of my students for the whole semester, they thought I'm Muhammad Reza. And I was like, mind blowing, mind blowing. How do I look like Muhammad Reza? And I was like, oh my God. So since then, every time I go to my tutorial, my first thing is tell them my name. And I'm like, this is my name. This is my email. There is no Muhammad Reza. I'm a girl. But anyway, yeah. I would feel bad if you do not know what your TA's names are, especially if you attend their tutorial. Because what makes me feel the worst is for problem sets they were handing during the tutorial. So basically, I always received his problem set means he was always here. So he definitely saw not he, I don't know, I don't remember. So they definitely saw my face and they still think I'm Muhammad Reza. So I'm like, I was doubting myself for the whole semester, and I talked to the other TA, Mohammed Reza. Was like, do you know one of my students always thought I'm you? But anyway, okay, I wasted too much time. What I need to do 102 now? I feel like I talk too much. Should talk less. There, do 102. So today we're going to do. Okay, for those of you who are watching the video, I'm sorry, I wasted 10 minutes of your 20 minutes of your life. Sorry, you go ahead. I apologize for talking too much. Now, today's material, we have image over function, we have field. No time for this, okay? No time for this. We'll do image. Field will be another video. So this will be another video. All right, so image was invested into your mental health. Okay, cool, fine. We can have other talks during other time, but tutorial is important because you need to get higher marks in your quiz and your problem set. Image, I know a lot of people do not understand image. Okay, sorry, I'll send it again. I know a lot of you do not understand image, so I'm gonna give you an explanation and I'll give you a bad example. Although it's bad, it's a terrible example, but I hope it can make you understand what's going on. So before we talk about image, we need to talk about domain and codomain. Domain, in this case, this is your domain. So domain, what's domain? Domain is whatever your x value can be, okay? Whatever your x value for your f of x, whatever your x value can be. And keep in mind that every element in your domain have to be used. They have to be used for your function. every one of them have to be used. So my bad example, again, this is a bad example. I apologize if you feel offended. I hope nobody feel offended. Is think about domain as the set of every girls. So think about this as a set of all the girls in a row. And B is your codomain, which is what your Y could be, but it doesn't have to be. So think about your codomain as the set of all the boys. So what the function is doing is mapping every girl to guy. So you're making them date. So now we're in a dating show. Okay, now we're in a dating show. And in this dating show, the rules are every single girl have to be mapped to a guy. So no girls can be single. So the first thing is no girls can be single. They have to map to someone. So that's every single element in my domain have to be mapped to something. The second thing is you cannot date two guys. Okay, you cannot date two guys. Each girl can only date one guy, one boy. So that's my second rule. You can only map to one element in the codomain to be a function. And the third thing is, now let's explain the difference between codomain and image. So I said no girls can be single, but in function, guys can be single. So we will have some single boys. My single boys are gonna be, no, sorry, I am sorry. Okay, it's a bad example, but it will make you understand. My single boys, they will be in my codomain. They are in the codomain, but they are not in the image. Does that make sense? Does that make sense? So every single guy who has a girlfriend, they are the image of the function. So terrible, okay, terrible example. Do not tell your prof, please. This is a terrible example, but it should make you understand. So in math, in function, that means if your y has an x that maps to it, then this y is in the image. If your y has nothing mapped to it, then it's not in the image, but it can be in a codomain. Can a boy have more than one girlfriend? Yes, they can. In general, they can. And when they can only have one girlfriend, that's called injective. And we'll know that. So when we reach injective, surjective, we will go back to this terrible example again. So single guys aren't in the function. Single guys are in the codomain, but not in the image. Does that make sense? And we will see. I'll never have two boyfriends. Well, okay. Anyone are still confused about image and codomain? Does this make sense? Again, it's a terrible example. I am sorry about this, but I just want you to make sure you understand. The image, so the image of the girl is the guys they're dating. So for example, if you have X, then the image of X, so after F, you map to F of X equals to Y. The Y is the image of X. So the image of a whole function is basically you put all the image of the elements together. So all C in C such that F of C, you put all of them together, that's going to be the image of a function. Yes, exactly. So guys with girlfriend, they are image, they are single, they are in the domain but not in the image. Exactly. Okay, So hopefully after this terrible example, you understand what's going on. Okay, so now you understand why image is a subset of codomain, right? Do you understand now? Okay, 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 cool, nice, nice. Okay, and later you'll see that we have injective function, surjective function, bijective function, and we'll come back to this terrible example. But I think that can make you understand it much, much more. So now go back to math. I'm gonna erase those. I don't wanna keep evidence of me using this. Remove the dating show. Yes, the guys who are dating the girls are the image of the function. Yeah. And the single guys are not in the image, but they are in the codomain. Cool, nice. Okay, let's do this. Example 1. Before I do this, I wanna tell you what does it mean if we have y is in the image of a function. Image of function is f of domain, okay? So what does it mean for y to be in the image of a function? It means this guy is dating a girl. So there exists a girl in the domain who's dating this guy. In other words, this means that there exists x in the domain such that f of x equals to y. And this is really important. This is by definition of image. And that's going to be helpful for this question. So let's look at this question. Proof. I want to prove this is a subset of this. What is this? This is an image of C intersect D. Okay, this is an image of C intersect D. It's a set. So you're proving one set is a subset of another set. Then what do? What's my first step to prove one set is a subset of another set?
Prove that it has the values.
Yes, so arbitrary value, exactly. Arbitrary element y. So let's let y be in this set. Why do we use y, guys? Because this is image, y is my boys, right? You cannot use x girls in this. Okay, so y in the image of this. What does this mean? I just mentioned, what does this mean? If y is in the image, what does this mean? This is saying there is a single guy for every single girl. No, you cannot have single girls. The first rule is all the girls have to be dating someone. There is a y for the domain. No. Here, look at this. Look at this. The thing in red that's giving you the hint. If y is in the image, then yes, exactly. Then there is an x in the domain such that f of x equals to y. So by definition of image, we know that there exists x in C intercept D such that fx equals to y. Okay, so we have x in the domain, which is what's in the bracket, such that f of x equals to y. So now I know x is in this. Then what does this mean? What does this mean? X is in C intercept D. What does that mean? X is in C and X is in D. Right? So we know X is in C and X is in D. And we also know fx equals to y. So what does this tell us about my f of x or y? What does this tell us about my y? No, fx equals to y. And x is in C, x is in D, then fx is in what? Guys, fx equals to y, x is in C, x is in D. So f of x, which is your y, is in what? Is in f of C and f of D. You need to put them in functions, right? Does that make sense? So we have f of C. No, I'm on y. F of x is y. So we have y is in f of C and y is in f of D. Now what does this tell us? Repeat, okay. F of x is y. So we have x is in C. That means f of x, which is your y, is in f of C. Okay, similarly, this is in D, which means f of x is in D. F of x is y, so y is in D. Does that make sense? Okay, cool. What does this tell us? No. What does this tell us? Remember, what is this? Right hand side, okay, exactly. So this is telling us, so y is in f of c, intersect f of d. That's the definition of intersection. So we're done. Which proves f of c intersect d is a subset of f of c intersect f of d. How do we know this is an image? F of domain is an image. Does that make sense? Yeah, f of domain is an image. So here is basically you restricted your domain to this. Your original domain is A, but your subsets of A, so you restricted your domain to C intersect D. So your dating show is we're not putting all the girls together. You're just selecting some girls, put them together, and matching them with guys like that. So this is your domain. So f of domain is an image. Anyway, my second question is this true that they're equal? True? False? Do they equal? This is done, by the way. First part is done. Second part, are they equal? Well, if you think they are equal, then you need to prove them, but are they equal though? They're not equal, right? False. Here is what I want to say. If you think a statement is false, if you think the statement is false, then you give me a counterexample. Do not try to prove a false statement. Okay, again, do not try to prove a false statement. If you think it's false, you give me a counterexample. Here is my counterexample. So my counterexample, I'm going to define f to be from z to z. And my c is 0, 1. My d is 0, -1. Then c intersect d is 0. So f of c intersect d Oh, I forgot to define f. fx equals to the absolute value of x. So this will be 0. However, f of c equals to 0, 1. F of d also equals to 0, 1. So f of c intercept f of d equals to 0, 1. And you're definitely not equal. Okay, that's my counterexample. Can we accept something like this or expect something like this? Explain this again. So I have a counterexample. So if you look at this, f, my a is all the integers, my b is all the integers, my f of x equals to the absolute value of x. Now I pick some numbers for my integers. So c is 0, 1, d is 0, -1. So c intercept d, which is the element that's in both sets, that's going to be 0. So f of c intercept d is 0 put in this. That's still going to be 0. Okay? But fc is 0, 1. fd is also 0, 1 because it's absolute value. So fc intercept fd is also going to be 0, 1. But 0 and 0, 1, they are not equal. So this is a counterexample. How do I know? Basically, when you have a true or false question, you try to find counterexample first. Because proving it takes so much more time. Finding counterexamples are taking less time. So for function like this, I always try absolute value and square. Those two functions almost like they always give you counterexamples. That's all I can say. So try those. The red part. This part. This part. This is so for all y in f of domain means for all not single boys. So for all not the boy for all boys who are not single, there exists a girl who's dating them. That's what it means. In the image means you're not single, right? So for all not single boys, there is a girl who's dating them. When trying to answer true or false question regarding sets, always attempt a counterexample. Use this, try to force it for a few minutes. If yeah, good approach. For set question though, if it does not involve function, then draw a Venn diagram always helps to see if it's true or false. Venn diagram. Another trick. Let me tell you another trick. Just for tests, okay? Do not think about it for assignment, just for tests. Is that if you see true or false question, yeah, Venn diagram helps a lot. For test questions, if you see true or false, and if you see that the statement, it's gonna take a long time to prove. For example, something like this. Prove the image is something. That's gonna take a while. However, you look at the mark, it's 2 marks for each question. 2 marks for a question like this, that's too much. So 80% of the time, that's gonna be false. For test only, okay guys, test only use it for test. So that's how usually when I see 102 tests, I see a true or false question and the statement, if it's true, it's gonna take forever to prove. Then I'm gonna say it's false and try to find a counterexample. Again, for test only. For test only. Do we have any other question before we move on to the next one? No, that's not what I meant. I meant if the proof is really long. The proof is really long for a true or false question and they're only worth a little bit, the most likely it's gonna be false. Most likely means not 100% sure. This is just a counterexample you came up with. It's not being fixed or something. It's basically a counterexample you came up with. It could be anything. But be remember that your counterexample should be as simple as possible, because if you try something really hard, justify it, it's gonna take a long time. So that's wasting your own time, especially during the quiz or during the test. So your counterexample should be as simple as possible so you do not waste too much time on it. Yeah, this is a domain, codomain. This is how I define my function. Why didn't you use R to R? It's still right. I can still use R to R. Yeah, doesn't matter. You can even use Q to Q if you want to. Okay? There is no special reason for me to use those. It's just a counterexample I came up with. There are many examples that works. For example, you can even change this to x squared and everything stays the same. See? Okay.
I have
Yeah.
a question. So regarding like your theory on kind of how to know if the answer is true or false. So
Uh-huh.
if we go back to the first question,
Uh-huh.
like so in order to prove that it's true, so the question has two steps. Prove that like the left-hand side is a subset of the right-hand side, and then it ask if it's true that they're equal, and then kind of prove it. So because we prove that the left-hand side is a subset of the right-hand side, so to prove that it's equal, we would have just done the right-hand side being a subset of the left-hand side.
Uh-huh.
So that like that takes more time than giving a counter example, but like
Oh
be,
no, that's not what I that's not what I meant. For something like this, I would first try false. You know why? Because if it's true, most likely they will just put equal sign here. Most likely.
oh,
It's like
okay.
for me, I'm like guessing what whoever made the quiz, I'm guessing their mind. So I'm gonna first guess it's false. Unless I cannot find an counterexample, I'm gonna prove it. But most likely,
Okay, I see. I see that. Okay, thank you.
well, don't tell your prof I said that. I don't think they have
I would
time.
never.
I don't think they have time to watch my video, so don't spread the word, okay? Keep it to yourself. Then you can always use it for the rest of the year in university, because that's how I did. I always guess what they think, and then I'm always right. That's how I predict my exams as well. I guess what they think, and I always guess right. Anyway, you should do that, by the way. You should make your own quiz, guess what they think, and you do that. It's a way to take tests, especially when you don't have time to review. Then I always guess what they will test me, and I only review those parts. Okay. Bad example. Sorry, I'm being a bad TA again. I'm a bad student and a bad TA. Okay, continue with this. This question is asking show the image of f is 0 to 1. What are they asking to show? It's basically asking to show f of r, because f of a domain, it's the image of the function. So it's asking to show they are equal. Okay? And to show this is a set, to show two sets are equal, what do I need to do? Subsets, exactly. You prove they are subsets of each other. So that's what we're gonna do. We first prove this is a subset of this. So hear me out, please. Important, really important. Let's let y be an element of your image. What does that mean, guys? What does it mean for y be an element of the image? The red part, red part. Exactly. There is an x in R, then there exists x in R such that f of x equals to y. Okay, so we have y equals to f of x, which equals to 1 over x squared plus 1. That's what I get from assumption. Now I want to show this whole thing is less than or equal to 1, greater than 0. Once you show this inequality, then you're done. How do I show this? So I'm going to start from x squared is greater than or equal to 0. So x squared plus 1 is greater than or equal to 0 plus 1, which is 1. And then you take the reciprocal. Remember, when you take the reciprocal, you need to flip the inequality sign. So this tells you 1 over x squared plus 1 is less than or equal to 1. Okay? Because I took the reciprocal, we need to flip the inequality sign. And now we also know that x squared plus 1 is greater than or equal to, well, let's just say greater than 1, greater than 0. And 1 is greater than 0. So we know that. So we know that it's always positive. Together, we have the whole thing is positive. Okay? So we show that this means that y, which is your f of x, y is this. And we show this. So thus y is an element of 0 to 1. That's the first direction. Any question? I'm so hot now. How would you find the image of 01? You find it in anywhere you want. Because 102, we only care about the proof. We do not care about how you find the image. Just find it the way you find the range in calculus. I see a hand raised up. Go ahead.
How come you're able to skip all the rough work?
Me?
Is it just with practice? Yeah. Is it just with practice and experience, or do you have a method?
Yeah, I barely do rough work in proofs. You can do rough work though. Okay, you can do rough work. It's just I don't have the habit of doing rough work for inequality, but you can definitely do it. Also, I feel like for those kind, you don't need rough work. It's simple. Okay, I should not say simple. Sorry, I apologize. It's not simple because it is greater than or equal to 0. Because we know it's a basic fact. Yeah, you start with a basic fact or you start with something you know. I know this is greater than 0. Okay. Yes, you claim it directly. So if you're not given an image, you find it and you claim it and you prove it. We do not care about how you find your image and do not show us. You don't need to show us. Just claim it and prove. Nah, we don't care about this anymore. Like by basic fact 1, you're an adult. Probably you're not an adult. Sorry. If you're not, I apologize. But we're grown up. You don't need to do it anymore. So basically, at the very beginning, when you just nerd something, then you need to code it all the time. And after a period of time, like now, basic facts, if you quote them, they are everywhere. Like for example, this I use basic fact, this I also use basic fact, this I also use basic fact. That's gonna waste too much time, so it's okay. You cannot use calculus, but you can use calculus to find the image and then just claim it directly. Yes, I will. The field will be another video. We're not gonna do a next tutorial. Next tutorial will have some other important things to do. Oh no, we're not done yet. We only proved one direction. We only proved this is a subset of this. We're not done yet. Oh, let's continue with the second direction, and I'll use two different ways to prove it. So first way, you can use quadratic formula, but I'll tell you why. Just give me a minute. Let me write down. Assume that, oops, wrong way. This way. Assume that y is in this interval. And now you want to show y is also in this. That means you need to show, so we need to prove, because you want to show it's in the image, so you want to prove there exists x in real number such that f of x equals to y. Remember, this is what you want to prove, okay? You want to prove your x is real. You want to prove your girlfriend is real. Otherwise, it will say you have an imaginary girlfriend, like that, okay? So you want to prove your girlfriend is real? How do we do that? So now it's the time you prove you actually have a girlfriend. Here, how do we prove it? We notice that if you have a girlfriend and she's not fake, she's not imaginary, then you have y equals to f of x. So this is kind of like rough work. If they exist, we have this, and this is gonna give you y x squared plus 1 equals to 1, which is y x squared plus y minus 1 equals to 0. And you see that this is a quadratic formula. So to show that my x exists, show that my x is real, and we have a quadratic formula, what do we do? What do we do? Quadratic formula, I want to show x is real. Quadratic formula, I want to show x is real. What do I do? Discriminant greater than or equal to 0, exactly. So the quadratic formula tells us there is a real solution if and only if, oh, what did I just wrote? Did I just wrote on if, if and only if your discriminant is greater than or equal to 0, which is d is greater than or equal to 0. So in this case, your d, what's your d here? B squared, b is 0 minus 4ac, so minus 4y minus 1 is greater than or equal to 0. So now you need to prove this is true, because this is my c. It doesn't matter. Yeah, because I don't want you to think this is your B. Yeah. Anyway, so I want to show this is true. How do I show that? I want to show this whole thing is greater than 0. I know that my y is greater than 0. So we know y is greater than 0. So y minus 1. Oh, I should say y is less than or equal to 1. So we get y minus 1 is less than or equal to 1 minus 1, which is 0. So that means this is negative. No, non-positive. Yeah, negative, sorry. This is negative. And also, we know that y is greater than 0. So negative 4y is going to be less than 0. So we have a negative number multiplied by a negative number. That's going to give you a positive number. So we prove that it's going to be greater than or equal to 0. Because it's a function of x, not function of y. Your y are just constant. You can consider them as your constant. B is going to be something multiplied by x, right? To say that the two negatives makes a positive. Yeah, that's what I did. Two negative makes a positive. You don't need to explain like that obvious thing. No, you don't need to. Skip which step? I didn't skip any step. You will not lose mark if you write like this, okay? Those are obvious steps. The not obvious steps are something like you divided by something, then you need to say, oh, this number is not 0. Here. So this tells you y is in between 1 and 0. Okay? So I'm done. I proved that your girlfriend is real. So now that's y is in the image. Okay? So we're done. This is the first way to show. There is a second way. Similarly, we use the same first two sentences. They are the same thing. I personally prefer the second way. But it's really up to you what you want to do. Okay. So the first two sentences are the same because you're just telling us what's your assumption and what you need to prove. Now we're gonna do 52 participants. What's wrong with this? I know a lot of you are not my students. That's okay. I don't mind how many students I have. Rough work. So now what I'm gonna do is I'm gonna do some rough work to find my x because I wanna show x is a real number. So I'm gonna do something. The rough work is y equals to x squared plus 1, 1 over x plus 1. So yx squared plus y equals to 1. Isolate for x. So yx squared equals to 1 minus y. So x squared equals to 1 minus y over y. This will give you plus or minus square root, but I'm gonna choose 1. So I'm gonna choose a positive one. But it doesn't matter. So you can choose a positive or a negative one. So this will give you that, but this is only rough work. So it doesn't matter. Now I'm gonna use my rough work and put it back into my proof. So let's let x equals to this. And you need to tell me if it's real number. It is a real number. Why? So just is fine. You because 1 minus y is greater than or equal to 0, and y is greater than 0. So the fraction is going to be greater than or equal to 0. Okay? Based on the interval, exactly, based on this. So I know it's a real number. Now I show that, well, there exists x in real. What I need to show now is f of x equals to y. So we plug it back in. So f of x equals to f of square root of 1 minus y over y. Plug it back in. That's gonna be 1 over square root of 1 over 1 minus y over y square plus 1. So this is 1 minus y over y plus 1, and here's 1. This equals to 1 over 1 minus y plus y. So they canceled out, this will give you y. So now I show that we have x in real such that f of x equals to y. So you're done. Done. Should be fraction greater than 0 rather than greater than or equal to 0. It can be 0 though. This can be 0. Can equal to 0 because your y can be 1. So when y equals to 1, this will be 0. Does that make sense? Yeah. So there are two ways. Personally, I love this way. I barely use quadratic formula, but it's really up to you whichever way you want to do. Okay? Any question? Question? Going once? We should get this recording with comments. When will the file? Oh, Phil. I have tutorial until 7 p.m. today, so it's gonna definitely be after 7 p.m. and I can record. So the first way, we need to include both 1 and 2. What's both 1 and 2? Oh, this, you always need this. The second way, first way or second way is just the other way. It's just this direction. But the first direction, no matter which way you use, you always need that. And the recording is on YouTube, which you can find the link on Quarkus. Bye. Whoever has to leave.
So the first part I need to I need to write it for next first and the second we just choose one, right?
Yeah, you can choose either way to prove the second direction, but the first direction you always have to have it.
Oh, I see.
When do we have the quiz next week? It's next Thursday from 6 to 7. Since x is an element of R, f of x equals to f of R. Huh? No, since x is an element of R, f of x is an element of f of R, not equal. What's the best thing to do to improve this course? I don't know. I don't know. We have, so a few TAs, including me, recorded a video about 102 tips. You can watch that one. It's in my Quarkus page as well. So it's called 102 study tips and Q&A. So you can watch that video. Definition of image, sure. So if you do not understand image, it's basically range in calculus. There's not much difference. The image of the function and the range of the function, they are interchangeable. It's just domain is a different thing. Any, do you need me to go over this once? Do you need me to go over this once again? I feel like my throat is on fire. I've been talking for too long and I talk too much.
I have a question, kind of just maybe analyze it. So first, the second way you approach question example 2, so did you basically like just get the inverse, and then prove it's kind of an
It's similar to that,
element?
but different.
Yeah, I see what you mean. Yeah, like you
Yeah,
got the
it's
inverse of the
similar to
function,
that.
but then sorry, yeah.
And you plug it back in, you get this.
Also, what you did is you got the inverse of the function, and then you wanted to see if like f of x equals to y, like the range equals to, like I get, like you just put the inverse of the equation of like equation into f of x. Like I see, it's just I don't have like
The
a word.
method is what you described, but the concept is not that.
Yeah,
I'm not sure if
yeah.
you understand what I'm saying. The
No, I
concept
do.
is different, but the method itself is similar to what you said. Yes.
Yeah, I see now. It's pretty fun, I won't lie.
I'm glad to hear you think it's fun. Nice, nice.
Yeah, I like the trick.
Bye guys, get out, get out. I have to eat. You can't stay here. Go away. I'll see you guys next week.
I want to know like which section will include in the quiz.
I have no idea.
Oh, okay. Okay.
You check the Quarkus announcement.
Okay. Okay.
Yeah.
Thank you.
Whoever DM'd me, can you email me, please? Because I really want to eat. I've been teaching from 10 to now, 10 a.m. to now, with no break. 9113. I think I am in, this is 9113. Yeah, yeah. So can you email me? Can you email me, whoever DM'd me? You probably don't want people to hear your name. Oh, not DM, email me. Yeah, email me. Okay, put the course code in the subject line so I know what you're talking about. Okay, I'm gonna stop here. Bye everyone. Whether you wanna stay or not, I have to go.